To revise cumulative frequency graphs. These are pretty popular on exams as well, which is why I've given you a quick it's time to revise worksheet and video on this. So the first question is, and have your GDC ready of course, the cumulative frequency graph below represents the speed s in kilometers per hour, so kmh to the minus 1 means kilometers per hour, of 80 cars passing a speed camera. So notice, where does the cumulative frequency graph finish? That's right, it finishes at 80. So that's important. Sometimes they'll make the graph kind of finish below the top, as in like you might think the maximum's 80, but maybe the graph finished down here, in which case the maximum would be 70, like the graph looked more like that. So just keep an eye on that. At least this one where it finishes is at the top of the y-axis, 80. So maximum of 80 cars passing a speed camera. So notice on the cumulative frequency graph, they kind of form these kind of little S-curves. We've got speed on the bottom in kilometers per hour, and we've got the cumulative frequency, like the running total along here. So question A, write down the number of cars passing the camera with a speed less than or equal to 50 kilometers per hour. So the number of cars comes from here, and the speed's down here. And what is the speed that they want us? They say less than or equal to 50 kilometers per hour. So that's here. So if you want, right there. So 50 kilometers per hour, remember, the way you can kind of show a bit of working out is you can do these dot, dot, dot lines. And so I'm kind of not using the board, I'm using the mouse pad, so sorry, it's going to be a bit slow drawing this. So what you need to do is from 50 kilometers per hour, read up to the curve and across. And as I said, these dot, dot, dot lines are ways that you can show you're working out. Sometimes you get method marks. Like imagine you read the answer wrong, but you had the correct dot, dot, dot lines. They might give you a method mark. So notice it hits 10, so 10 cars. And first of all, are they asking how many are more than 50 kilometers per hour? So more than 50 kilometers per hour would be from 10 to 80. So 70 cars are more than 50 kilometers per hour, like these speeds. But they're not asking for that. They're asking how many are less than or equal to 10 kilometers per hour. So in which case that would be just 10, just this little area here. So 10 cars is what I can write there. 10 cars would do fine. So we've read that from here. Now let's go into the next page, flip over. B, complete the following grouped frequency table for speed. The speed of the car passing the camera. So this, I've noticed this kind of question has popped up on quite a few math studies exams in the past few years. So that's why I've included that one in here, because it's we didn't used to get questions like this, but now you do seem to get them almost every year. So notice, to give you, like they're saying 0 to 50, 50 to 70, 70 to 80, 80 to 90. And those numbers come from the bottom here. So if you're a bit unsure, let's see, how did they get 34? Let's see, 70 to 80. How did they get 34? So going from 70 to 80, so 70 to 80, I'll just change the ink to green. 70 to 80 is between here and here. So on the graph, 70 is at about here, and 80 would be up here somewhere. So 80 kilometers per hour connects with this point here. Let's see. And therefore, how did they get 34? Oh, actually, do you know what? It doesn't quite connect with that point. It connects more with this one, that's why. So that's how they're getting 34. Because see, 70 connects up with 30 cars, and 80 kilometers per hour as a speed connects up with 64 cars. And 64 cars, so the difference between these two vertically, this distance here would be 64 minus 30, which is 34. That's how they got that 34 there. Also, if you're not sure, 90 to 100, let's see, oops, going the wrong way, just to point out how they do this. So do this one in blue. 90 here connects up with this point here, so that's about 76, as you can see. 100 here connects up with that point there, which is 80. What's the difference between 80 and 76? That's right, it's 4. So that's how they're getting these values. So we can use the same method to find the other values. So let's do 0 to 50 first. Because notice they're not going up evenly, so just do whatever they've got, 0 to 50. 0 to 50. So 0 is here, connects with that point there. 50, as we know, connects with this point here. And what's the distance vertically along here between where it connects for 50 and where it connects for 0? That's right, that's 10. 10 minus 0 is 10. So in the first one, we can fill in 10. That's easy enough. Now I might do the next one in yellow. This is 50 to 70. So go across 50 to 70. So 50, of course, we know connects up with 10, that little yellow point here. 70 connects up with 30. So what's the distance between 30 and 10? That's right, that's 20. So 20 cars belong to this group here. It's a weird looking 20, I know. Now let's do the next one. What colour will I do it in? Let's do it in a pretty blue. 80 to 90. So let's go back here. 80 to 90. I know it's a bit tedious, but just do it really carefully. 80 we already know connects up with this point, which is 64. And 90 connects up with this point here. You can see 90 down here, connects up with this point here, 76. So what's the distance between 76 and 64? I tell you what, if you're not sure, just work it out. 76 minus 64. Let's try it on here. 76 minus 64, 12. So that distance there is 12. So 12. Notice there's a gap missing. Let's see. So see, I've done that one. This one's missing because this one's been worked out already on the table, 34. That's that one there. And the last one's been worked out, so no need to fill in them. And we know there's 80 cars in total, so you can check by adding them all up. Let's see, do these frequencies all add up? We've got 10, because we know there should be 20 cars in total. 10 plus 20 plus 34 plus 12 plus 4. Good, we get 80, so we're good. Tick. All right, so we've filled in the cumulative frequency table. Write down the mid-interval. So by mid-interval, they mean mid-interval value. They're asking for the midpoint. So mid-interval value, they're asking for the midpoint of 50 to 70. If you're not sure how to do that, you can just add 50 and 70 together and divide by 2. So it's so slow writing like this. They're asking for the midpoint. So we can do 50 plus 70. I'll do it here. 50 plus 70 all over 2. So I'll do that with a pen. All over 2. 50 plus 70 over 2. If you're not sure, plug it in the calculator. Let's clear this. Alpha y equals, to make nice fractions, n/d. Nice fraction setup. 50 plus 70. You've probably already guessed that the answer is 60. So of course 60 is the midpoint of 50 and 70. But imagine the numbers weren't that easy. That's how you would get it. So the answer is 60 equals 60. So that's called the mid-interval value of these two. So the mid-interval of this one is 60. That's the midpoint. And the answer's down here. Use your GDC to find an estimate of the mean speed of the cars passing the camera. So remember, this is going to be your L1. The little midpoints will be your L1 in your, we're going to do stat edit, of course, and enter in 2 tables of value. We're going to enter in L1 and we've got to enter in L2. Because when you find the mean from a frequency table, you've got to have your x value, and our x value in this case will be the midpoint. What's the middle of 0 and 50? That's right, it's just 25. What's the midpoint of 70 and 80? That's right, it's just 75. If you're not sure, add them together, divide by 2. Middle of 80 and 90, you're right, it's 85. 90 and 100, that's right, it's 95. So we're going to go stat edit, and we're going to enter in L1, we'll enter in our mid-interval values, our midpoints, and in L2 we enter our frequencies. So let me demonstrate that for you. Grab out your calculator and do it too if you like. So clear, so it's a statistic we're finding, it's mean. So it's stat edit. So just press enter to select edit. Now I've got some mess going on in here, so remember to delete them, go up here and press clear and enter. Or you could alternatively delete the separate things like this. But if you go up here, don't press delete because it deletes the whole thing, and then you'll have to reset the memory to bring it back. So, okay, so see L1, L2, L3, L4, everything's great. So if you ever do delete this by accident and you want to see how to bring them back, watch my video for, I think it's either for the mean or for Pearson's and linear regression, and I show you how to reset the memory so you can bring back L1 if you delete it by mistake. But you don't want to get to that point, so don't do that. So I've got to enter in 25, 60, 75, 85, 95. So of course make sure to enter it properly. 25, 60. Feel free to pause and just enter it yourself. On your calculator, it's always, you'll remember more if you do it yourself rather than just watching. And then now we enter the frequencies, 10, 20. These are the coloured ones, 34, and 12, which I've got in blue on my table, and 4. Really easy to type in a wrong number, so you should check them over now. So let's check. 25, 60, 75, 85, 95. Yep, that matches this. 10, 20, 34, 12, 4. That matches that good. And so, because I said it's so easy to type in the wrong number and get everything wrong. Now, mean is a statistical calculation. So once we've entered in our data lists, go stat, calc. So go across to calc. And it's a single one variable statistics. One bar stats. Our L1, so I'll just delete these so that you can see what you would do if there was nothing there. So if this was empty, we've got to tell them that our first column is L1. X data is in L1. So to do L1, you go second 1, and that makes L1 happen. Imagine like maybe it had L3 in here by mistake. So if it did, what would you do? You would have to go back and enter in L2. So you could delete or just type in L2. L2 is second 2, because it's saying where are your frequencies? Our frequencies are in the second list, L2, and our X values are in the L1 list. If it was just one list of data, and it's not a frequency table, you should leave this one blank. But because it's a frequency table, I have to have something in my frequency list. If it wasn't a frequency table, and it was just a list of numbers that they want you to find the mean of, leave this blank and then go down to calculate. But this is a frequency table, so let's do that. L2, calculate. What's our mean? 67.5. There it is. So don't erase anything from the calculator, because maybe it needs something else from there. 67.5. So let me point out what else has popped up on the calculator for us. Let's see, we've got the standard deviation. It's not the S of X, it's the fish, the sigma X. That's our standard deviation. We've got the lower quartile, Q1. Scroll down, you'll see we've got the median, 75. We've got the upper quartile, Q3, and so on. Let's see, did they want any other information? Part II, the standard deviation of the speed. So the standard deviation was that sigma X. So you might want to, I would strongly suggest, you don't have to write sigma X, but I would very strongly suggest write it out to lots of decimal places before you round to 3 sig figs. So I'd write out 18.6413 ... 18.6413 ... then round to 3 sig figs. So then if you make a mistake rounding to 3 sig figs, the examiners might still give you the full mark, but only if you wrote the unrounded answer first. 18.6. And let's see, do we have any units? I've probably missed out some units, and I don't want to lose marks just for not writing units. So the mean speed was kilometers per hour. This one, kmh minus 1. So let's add some units in there. kmh minus 1. Such a shame to lose marks just for something as little as that. And standard deviation for the speed, same thing. kmh minus 1 means kilometers per hour. So you could have written /h if you prefer, but let's just write what they've got. Lovely. There you go, so that's question 1 finished. So yeah, as I said, go back and double check that you put in units and that kind of stuff. I could have probably put units here too, so alright, let's just do it then, fine. You've convinced me. kmh minus 1. And write it a lot neater than I did. Okay, now let's move on to question 2. Different question, different graph. For the cumulative frequency diagram showing bug length, so the length of bugs, eek. So we've got length in millimeters down here, and we've got the cumulative frequency down here. So that should really say cumulative frequency. Like the one here says cumulative frequency. This one should say that too. So feel free to write that on there if you prefer cumulative frequency. I'll put C because I can't write properly with this in. Find the median. So this is more, how do you interpret cumulative frequency graphs? So let's see, what's the maximum? The maximum is where the graph finishes. The graph finishes here. So that's our max there. So our maximum, so there's 40 bugs in total that were measured. 40 bugs in total. Be careful, sometimes the graph might finish earlier than the top. So if it finished here, the maximum would be whatever that is, like 35 or something. Find the median. To find the median, you go down to halfway along the cumulative frequency and read across and down. So what's half of 40? Half of 40 is 20. So go from 20, read across to your dot, dot, dots. I'm trying to do them really carefully, but sorry, it's hard with this mouse pad. Dot, 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 dot. All the way across. Use a ruler, please. Please bring a ruler to your exams. Down, down, down. I'm just checking what the answer's meant to be. Yeah, it's a bit of a tough one to read, actually. So you do this to get your little method mark. I've lost where I was. I think I was there. The answer to this is meant to be 25. What have I done wrong? So it's gone 10.5, then it goes up by 5, 15.5 plus 5 plus 5 is 25.5. So I think it should be 26. So let's just say mine was a bit off. I should have kind of gone more across like that and down there. Let's just undo all that. See if I can find a better way to do it. Let me use this dot, dot, dot line. See if I can use this cheat method. Okay, let's try this. Trying to keep it straight. That was a fail. Okay, all right. So let's just say 26. So what you do is you look to see where the maximum is, where the graph finishes. It finishes at 40. Go halfway down, and then you find your median. So that's the median down here. Med, which we got to be about 26. Find the interquartile range. Remember interquartile range, IQR? What does it equal? That's right, it equals Q3 minus Q1. Q3 minus Q1, and that should be a subscript. How do I do a subscript on here? Yay, cool. So Q3 minus Q1. So the upper quartile is, you go down from the median, go up halfway between the maximum and the median. So Q3, what's halfway between 20 and 40? It's 30. So do your dot, dot, dot. I'm going to do it really rough this time. It's taking ages, sorry. And again, if I've made a boo-boo, I'll let you know. I've got my correct answers down here somewhere. So it's Q3. That's called the upper quartile. Upper quartile, we should get about 34, that's meant to be. Or whatever. So from 30 across, let's see, it's really hard. Like, you'll have better graphs in your exams, but this is a pretty crummy one. Mine's saying 34, but that doesn't seem like 34 to me. It's because I'm looking at the wrong answers. That's better. Okay, sorry. Yeah, so this makes more sense. 28 I got for this one. I'm looking at the wrong answers before, sorry. So for the top one, for the median, which makes more sense, I initially got 28. Sorry to mess you around. 28, what are the units for bug length? That's right, it's mm. That's better, because that matches more what we did here. That's what was throwing me. Okay, Q3 minus Q1. What did we get for upper quartile? When you read across and down, about 31.5. This ended up equaling. It's hard to get it accurate because it's a crummy graph. 31.5. Now in purple, find the lower quartile, Q1. Go down to halfway max, go down to halfway where the median was used to find, and then halfway down from that. So the lower quartile would read across from 10 and down. So again, just doing this really roughly. Q3. No, sorry, that's Q1. So Q1, let's see, reading that, we should get about 23.5. 23.5, plug that in the calculator, 31.5 minus 23.5, what does it equal? Our interquartile range, therefore, is about 8. What's our units? Millimeters. Now this is crummy. Hopefully the next video I'll be able to get access to an actual smartboard and make a bit of video for you. So to find the 90th percentile, work out what's 90% of the maximum. Maximum's 40. So 90% of 40 90% of 40 equals, show on the calculator how you can do that, 90 over 100, or use fractions if you prefer, alpha y equals n/d, 90 over 100 is how you make a percent, and then times it by whatever you're trying to find the percent of. 90 over 100 times 40 gives you 36. So what they're trying to do is help us to find, so that means go up to 36 and read across and down. Here's 36, 36, read across and down. It's easy. So find out what 90% of the total is, total number of bugs, and then from that read across and down. So the 90th percentile was, whatever that answer is, about 38. 38 mm. Again, sorry, it's so hard to write on this board, on the computer with a mouse pad. That's about 38, like it's pretty rough again. How many bugs were less than 21.5 millimeters? That's easy. Just go to 21.5. Let's see, where's 20.5? Yeah, it's pretty messed up, this. So 10.5, 15.5, 20.5, 21.5 is about here. Read across and down, I'm just doing it roughly. Again, you'd have a much better graph. So we're just going to here and reading across and down. So our answer should be, that's about 7 bugs. So see, because 10's up here, 5's there, 7. Normally they allow plus and minus 1, but you'll have a much more accurate graph for yours. And that's the end of cumulative frequency. Thanks for watching.